So today's lesson is on prime factorization. And if you don't know what prime factorization is, it's going to make it hard for you to understand how to do it. So when you're finding a prime number is a number that has only factors of 1 and itself. For example, the number 3. The only numbers that I can multiply to get 3 are 1 and 3. And there are many, many other numbers that are prime numbers. Factorization is finding all of the factors that go into a number. So for example, we're going to be finding the prime factorization of 180. Choose any two factors whose product is 180. Continue finding factors until only the prime factors are left. So one way we can do this is looking at our number and seeing that it ends in a 0. So we can use a basic fact. We can think, okay, 10 times what is going to give me 180? And it's going to be 10 times 18. So that's what we're going to put in that blank there. 10 times 18 gives us 180. Then we'll look at the factor tree itself. So, whoops. Put our 18 back up here. So if we use 10 and 18, now we need to find the factors of 10 and 18. For 10, they already gave us a 2. So we have to think 2 times what equals 10? Well, that's 2 times 5. For 18, we have to think, they gave us a 6. 6 times what is 18? Well, that would be 6 times 3. 5 is a prime number because the only factors are 1 and 5. So we're going to put that down in the bottom. 2 is also a prime number. 6 is not a prime number, so we need to branch that off again. To multiply, what numbers that we need to multiply to get 6 would be 2 and 3. And then 3 is a prime number already. So the prime factorization for 180 is 2 times 5 times 2 times 3 times 3. If you multiplied all these numbers together, you will get 180. So that's one way we can do it, by using a basic fact. But there's another way. And that's what we're going to look at next in part B. So let me scroll to our next page. This one wants us to use a divisibility rule. They want us to use the rule of dividing by 2. Since it's an even number, we can divide it by 2. Any even number can be divided by 2. So 2 times what equals 180? That's going to be 2 times 90. Oops. Get my marker out. 2 times 90 is 180. So now they want us to use that to start our factor tree. So I'm going to write 180, and we branch off. We have 2, and we have 90. Now 2 is already a prime number, so we don't have to worry about that, but we do have to worry about 90. We're going to keep using this divisibility of 2 because it's still an even number, so we have to think 2 times what gives us 90? 2 times 45 is 90. So we'll bring this 2 down because it's still a prime number. Bring it down again. We have a 2 here from our 90. That's going to be brought down, but we have to split 45 because it's not a prime number. So now we can think, what numbers can we multiply to get 45? And that's going to be 3 and 15. So we have 2, 2, and 3. Those are prime numbers, but 15 is not. Once again, we have to break off from 15. For 15, we have 3 and 5. So now we are left with only prime factors for 180. Once again, that gives us 2 times 2 times 3 times 3 times 5. Same as the first way. We've got the same answer. So that's 2 different ways. Clear this off. Okay, we're going to look at the next way. Now we're going to take a look at another example. This one wants us to use the ladder diagram. So if you turn to page 12 in your book, part A and B, we're looking there again. They have the ladder drawn up for us to find the prime factorization of 140. They want us to use the divisibility rule for 2. So what they did was they took 140 and they divided it by 2, which is 70. Then they took 70 and we have to figure out what times 10 gives us 70. And that's going to be a 5. I'm sorry, not a 5, a 7. Oh, why are they doing this? I'm sorry, guys. I don't like how they did this. Erase, please. So they put the 7 there. So 7 times 10 is 70. Now we need what times 2 is 10. That's where we're putting our 5. 5 and 2 is 10. Then we need to look at what are our factors of 2. 2, 1 times 2 is 2. So our prime factors are all along the side here. 2 times 7 times 5 times 2. I don't love this ladder. It makes a little bit more sense to me to do it as the factor tree. So even if it's asking you to do it as the ladder, if you would prefer to make it into a tree, I'm okay with that. Whatever makes the most sense for you. So now we're going to look at another example. We're going to actually go to number 1 on page 12. And it wants us to use a factor tree to find the prime factorization of, not 180, 18. There we are. I love the way factor trees work. I think they're so much less confusing than that ladder. I don't like the ladder. If you like the ladder and it makes sense to you, feel free to use it. So for 18, they already started breaking it down for us. 6 times what is 18? 6 times 3. 6 is not a prime number because we have numbers that we can multiply to get 6 other than 1 and 6. So 2 times 3 gives us 6, and 3 is already a prime number, so we can bring it down. So the prime factorization of 18 is 2 times 3 times 3. Okay? Now let's look at the next one. Let's look at number 2. It's a ladder. But I'm going to take it and I'm going to come over here and I'm going to make it into a tree because I don't like it. I don't like the ladder. So if I make 42 into a factor tree, 42, and we're going to branch off here. We need to think, what are some factors? It is an even number. So what can we divide? If I wanted to divide it by 2, and we can kind of use these over here to help us. 2 times what gives me 42? It's 2 times 21. 2 is a prime number, so I'm just going to bring it down. 21 is not. 21 would break apart into 7 and 3. 7 is a prime number, only can be multiplied by 1 in itself to get 7. So our prime factors for 42 are 2, 7, and 3.